In mathematics, we often solve for x, but what about y? Today, let's talk about why a squared plus b squared equals c squared, or in other words, why does the Pythagorean theorem work? This theorem is probably something you've memorized in school, but I want to go behind the scenes and really investigate why does a squared plus b squared equal c squared? Just as a disclaimer, this is only one of many proofs of the Pythagorean theorem, so if you're interested in this video and want to see some other ways we can visualize this, be sure to check out the other videos on my channel. As a refresher, the Pythagorean theorem only works on right triangles, so let's get a right triangle up here. We'll go ahead and label our sides. We have this green side we can call A, this blue side which we can call B, and the hypotenuse, which is the longest side of the triangle, we can call C. So the Pythagorean theorem says if we take each of the legs, or the shorter sides of the triangle, square them and add them together, we will get the same value as taking the hypotenuse and squaring it. Now, just for fun, let's take 4 copies of our triangle and arrange them to form a square of side length C. And you'll probably also notice that a smaller square has formed in the center of this square. Let's talk about area. We know that the area of a square is equal to the length of its side squared. But in our case, we also know that the area of this total square would be equal to the area of all of its pieces added together. So the area of this big square also equals the area of the 4 triangles plus the area of the center square. Starting with the big square, it has an area of c squared. To find the area of the 4 triangles, we can look at just one triangle, and we know that the area of a triangle is equal to 1/2 times base times height. So in our case, we would have 1/2 times a times b. It doesn't matter whether you do a times b or b times a. Depending which way you're looking at the triangle, either one could be the base, and we know that multiplication is commutative, so it doesn't matter which order we do it in. But we have 4 of these triangles, so we will multiply that area by 4. And finally, to find the area of the center square, we first need to determine the side length. Notice if you take this blue piece, which has length b, and subtract out the same amount of the green piece, or length a, then that leaves us with the remaining piece for the length of the square. So in other words, the side length of the red center square is b minus a, and thus the area of the center square would be b minus a quantity squared. So now we have an equation that is true. The area of the total square equals the sum of the area of its parts, and we just need to simplify it using algebra. So we have c squared equals 2ab plus b squared minus 2ab plus a squared. Notice that we have a 2ab and a negative 2ab, which will cancel out, leaving us with c squared equals b squared plus a squared, or if we simply just rearrange the terms since addition is commutative, we have a squared plus b squared equals c squared. So that's why the Pythagorean theorem works. Now, instead of memorizing it, you understand visually why a squared plus b squared equals c squared for right triangles.